Good morning, students. I had created my first video for you for the lessons for quarter 3, milk 1 and milk 2, which is about illustrating the permutations of objects and solving problems involving permutations. I am your mathematics teacher, Ma'am Churchill, and I will guide you with some examples and discussions about this lesson. So you might be wondering why there are two learners material that you are handling right now. The first one is your learning activity sheet, while the second one are the pages photocopied from your learner's material or your textbook. This one is your LAS, while this one is your LM, or the learner's material, where you can have your additional references about the topic. And I am making this video to give you additional reference and additional discussion about our lesson. So I hope this will guide you throughout the remaining quarters of our school year 2020-2021. So let us now start. The first lesson that we will be having is about permutation. So what is it? A permutation is an arrangement of n objects with no repetitions in the order is important. So take note the highlighted word, the permutation, and order. This is an arrangement of letters, numbers, or any objects where the order is taken into consideration. So let us have the three cartoon characters, SpongeBob, Bugs Bunny, and Mickey Mouse. So this is their first arrangement. We can also arrange them as this one. Wherein here, Bugs Bunny comes first before SpongeBob, and the third one here is Mickey Mouse. So this is an example of permutation. We will be arranging any objects where we will be taking into consideration their order. So let us have another example. We have here three shapes: the square, the circle, and the triangle. So how many permutations are there? First one is this. Second. Third. Can you guess what will be the fourth arrangement? This one. This will be the fifth. And this will be the last. So there are 6 permutations. If you would notice, in the first arrangement, we have the square, the circle, the triangle. And the second one, we have also here the square. Next is the triangle, while the third one is circle. In the third arrangement, we have here the circle, the square, and the triangle, and so on. So if we will be arranging the three shapes with no repetition, or hindi natin inuulit kung hindi na natin ginagamit yung naunang square, ilalagay pa dito yung another square, wala na siya. So, hindi na inuulit ang object sa iba't ibang position. So, we can have here 6 arrangements. So, for you to easily solve it and hindi kayo masyadong mahirapan sa paglilista, this one is a listing method. We can use the counting principle by making your blanks here. There will be 3. Bakit 3? Because there are 3 shapes involved. And what are we going to do with this one? We're going to have here 3 objects or 3 shapes. Now, if we had used one of the shapes here sa first position, on the second, hindi na natin siya pwedeng isulat or ilagay dito, kaya naman it will be only 2, and this one would be 1. What are we going to do with this? We are going to multiply. So we will have 3 times 2 times 1, which is equal to 6 permutations. So there will be 6 arrangements of the shapes with no repetition. Second example, we have 4 letters, the letters A, B, C, and D. So we are going to arrange them. Some arrangement or some permutations are A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B, B, A, C, D, and B, A, D, C. So how many permutations are there? So to facilitate the answer to this question, let us have 4 blanks. 4 because there are 4 letters. So what number are we going to place here? It will be 4 kasi 4 na letters. Now, kapag ginamit na natin sa unang posisyon ang isang letter, sa pangalawang posisyon, syempre mababawasan na siya ng isa. It would be only 3. While on the third one, it would be only 2, and on the last will be 1. So we will multiply them. 4 times 3 times 2 times 1, that would be equal to 24 permutations. So meron na tayo ditong 6 na arrangement ng letters A, B, C, D. And all in all, kapag in-arrange natin to, there will be 24 arrangements or permutations where we can get or where we can obtain from the letters A, B, C, and D. Let us discuss now the factorial notation. If you have here this notation, this is read as n factorial, which would mean that it is equal to n quantity n minus 1, quantity n minus 2, quantity n minus 3, and so on 2 times 1. Take note that 0 factorial equals 1. If we have here 3 factorial, that would mean 3 times 2 times 1 equals 6. If you have your calculator, you can just press 3, and this notation on your scientific calculator, it gives you right away your answer, which is equal to 6. 4 factorial means 4 times 3 times 2 times 1, which is equal to 24. So in general, if we have the number of permutations of n distinct objects taken n or all at a time, it is n factorial. So in our notation, n distinct objects taken all at a time equals n factorial. That is, if we have one object and we are going to arrange them all in one time, that would be n factorial. How about if we have permutation of n distinct objects taken r at a time, where r is less than or equal to n? So that is n p r. Given n distinct objects, suppose we take r objects at a time, in how many ways can the r positions be filled from the n objects? So our formula for that will be n taken r at a time equals n factorial over quantity n minus r factorial. So we have two formulas discussed. First one is the n factorial, and while the second one is n factorial over quantity n minus r factorial. Let us have an example for that one. Suppose we have here 6 children with 6 chairs. In how many ways can 6 children be seated in a row of 6 chairs? So 6 na mga bata uupo sa 6 na upuan. So we are going to arrange them one at a time. We will have 6 taken all at a